welcome. And with that, I think I see Kevlin is on LinkedIn too. Hello, Kevlin. Welcome to the show.
Hello and good evening. And yeah, lovely to be here. Thank you very much.
It's very much an honor to have you. It's a great opportunity to talk about so many things, but I obviously have created this format that other people ask the questions. So I have the honor to introduce you. Kevlin Henney, you are a well-known speaker and author, and I especially find it interesting to have someone on the show which is not just known for their C++ creations, but does definitely have that also in their vita. Like you are a Boost author, which some people might not know, and there just has been an article on SCD-Any, and that made me wonder, like, what's your opinion on Any today? But maybe someone wants to ask a question.
Yeah, so somebody who wants to ask that, I'm more than happy to ask, because it's had a very long history.
And with that, let me see if there's any questions in the Hobido Q&A tab. So if you have any questions on Hobido, post them to the Q&A tab. I'll be watching out for that. And if you want to ask a question in LinkedIn, directly post it to the chat, and I can just read it to Kevlin to start the show. Let's start with an easy question. How's it going for you?
It's going all right. Thank you very much for asking. Yeah. I think things are mostly okay. Things are mostly good. I've found that the last couple of years, the last 3 years, have changed the balance of my work. I seem to be doing a lot more remote work, and that's kind of stayed. But the kind of work that you can do sometimes is quite interesting in terms of running workshops. The structure that I use is very different now. I tend to spread it out over many weeks, and people bring their problems on a weekly basis and things that we do. So yeah, the shape of my work has mostly changed. But yeah, no, it seems to be heading in a new direction. So we'll see what happens over the next few months.
I see. So one thing you're very well known for on social media is a meme, and I thought that, be a great starter to just what do you think of it? How it got started?
Yeah, so as it's known, and at Kevlin Henney, it basically people will. Originally Twitter was where it kind of grew up, but with the recent kind of balkanization of social media, it now pops up. I'm on Mastodon, I'm on Threads a little bit, I'm on Blue Sky, and so on. People will send me, they will at me error screens that they've spotted, and I will typically retweet these. And depending on the social media thing, I will normally like it. So that means if you go to Twitter, for example, and look at all of my liked tweets, they are all error screens. There are thousands of them. And this ultimately started because I think it first started with me taking screenshots of applications crashing. And then we ended up with cameras in our phones, and I would take photos in different locations. And I wouldn't do anything with these. I wouldn't do anything much. I would just sometimes include them in slides, in talks, or in workshops and training courses where I was making a point about the nature of software or the nature of a bug. And sometimes you can see this. I think one of my earliest shots was PowerPoint busy crashing, but left me a little screen, and it told me that there was a pure virtual function had been called. So immediately at that point, you've got a number of possibilities. First thing you know is that this is written in C++. The next thing you know is like, well, under what circumstances can a pure virtual function be called? Standard one of those is perhaps calling a pure virtual in an abstract class, constructor or destructor, and that kind of error is very, very common. That can happen, or it's a memory trampling error and something's got mem set to 0, and this kind of thing. So you see the nature of how the software is created. You start seeing what it's made of, and you start seeing its error modes and so on. So I would show these to a few people in talks and things like that, and then people started sending them to me. And then we hit the year of social media, and people started just sharing them directly, and particularly Twitter. People would at me, and I would just simply, retweet it. And then around 2016, somebody, it was obviously happening enough that somebody said, "Oh, I was just going through the airport and I spotted a Kevlin Henney screen." So suddenly my name got attached to it properly, rather than just people, a Kevlin Henney screen. And it kind of stuck, a Kevlin Henney. And so that name has appeared, I don't know, in Urban Dictionary. It's appeared on the register, and it does the rounds. And so it's kind of fun, it's interesting because, it's interesting from one point of view. My name is associated with failure. I don't know how I feel about that. But from another point of view, it always gives me something to talk about when talking about the way that we construct software and the way that software can fail. It also has an interesting side effect. I've noticed that for some of these, particularly train stations, whatever the country, people will normally at the train company as well. And often the social media person will respond and say, "Oh, I'm really sorry about this," or "Which station was this? We'll see if we can get it fixed." So it does act as a public service in that sense. So I think I'm okay with it. I think it's quite fun. I think it can be educational. I think it can also encourage us to think about the broader implications. It's very easy when we write software to just focus on, here it is in the code, in my IDE, on my screen, and that's my universe. And it's very easy to forget that actually the universe in which the software will run is quite a separate thing and will affect people, sometimes in amusing ways, but sometimes in more devastating ways. We've had a number of examples of software failures recently that are interesting. Toyota ran out of disk space, which shut down all of their factories. So obviously there was a piece of software that didn't check disk space. The whole of the air traffic control region over the UK was shut down for a few hours last week, which caused days of chaos and absolutely millions, if not billions, of losses because basically some input data was not checked, and a thing that could not happen did happen, and therefore shut down the system. So in that sense, it was good that it didn't. You didn't use garbage data to try and control the skies. But actually what was interesting was how simple the failure was in some senses. And it's a classic test case. And that there are many more rational responses to it than shut the whole system down. So we find that these little oversights, they're for us, that's just like, oh, that's a bit of a shame, or that's a bit awkward. Sometimes they amplify to be something far larger.
Yeah, actually, let me quickly put that in screen. I had a Kevlin Henney today. My hoster told me that my disk space is none of none, which I guess is
my
just
favorite one.
But so is that too much, not enough, or I don't know. It's probably some JavaScript error.
Oh, that's good. I like that.
I have none disk space of none. And yeah, but let's not get into a debate about floating point numbers. So we'll continue with the next question. There's a question. Last year at CPPCon, we heard about CPP2, last keynote by Herb Sutter, and he has since then continued the work on that. What can you say about this?
Not a lot. I can say a little bit about it. We seem to be going through a phase where people are looking for almost a successor to C++. And there are different ways in which people have phrased this. And I think that Bjarne said many, many years ago that inside C++ there is a small language trying to get out. People have variously at different times talked about subsetting, but there's this idea that C++ is, top 5 most popular languages, but it's not easy, and each successive standard does not make it easier. Although there's a lot, the people on the folks who participate in the committee often have very different agendas. There's certainly a willing desire to try and make things easier for people. But the normal thing is that it's trying to make it easier by adding things. And actually, you make things easier by removing things as well. Otherwise, you just have more to learn. And people have become much more fascinated by the idea, and perhaps because we live in an era of many languages, there's an exploding number of languages, by the idea of, can I have C++ that kind of gives me the power of it, but perhaps not all the historical baggage? Sometimes the gotchas, the surprises come about from history. And we also have increasing concerns about safety. And C++ is, although in many ways safer than C, there are constructs that are as equally available that are unsafe and safe. If you are a new developer to this can be overwhelming. The amount of stuff that you need to know and that you need to not do and the things that you need to do can be overwhelming. So I think a lot of people are looking and saying, well, can I have all of the stuff, the low-level access, the ability to do almost anything that I want, but not necessarily with the language as it stands? And, we're seeing CPP, things like CPP2, Carbon, and there are other things going on, as well as in a very different track, the rise of Rust as being native languages with a focus on efficiency, but also saying maybe we don't need all of the other things that came with C, that have come with C++, because at this point in time, C++ is heading towards its 50th birthday. Strictly speaking, it's heading towards its 45th birthday will come first. I think that's next year. I think Bjarne said it's 1978, 79 is when he created the progenitor of what became that. So, but we're not far off half a century. And a language picks up a lot of stuff in that time. And I think sometimes people say, well, could we have something else? And this notion that C++ is being, in certain environments, is being deprecated because of safety concerns. We see studies from Microsoft and Google talking about memory-related errors and these questions of security issues that come from things like buffer overruns, attacks that come from those. Just simply, can we make things a little bit simpler whilst embracing what we've learned? So I can't give you anything specific on Herb's design. I've only looked at it very briefly. I certainly haven't watched the keynote, but it is one of a number of things that it's kind of I'm aware of that I think are moving in interesting directions and do seem to be influencing some of the things that people are talking about on the committee.
Yes, and there's the first question which directly fits into our topic, which we're on. Do you think there will be an ARBI break in the future of C++?
I think there has to be. Because the whole concept of what C++, the obvious thing, C++ grew from C. C has a very simple, conventional idea of what an ABI looks like historically, and so it's at a very primitive level. What is needed but the thing is that C++ is not simply C with classes. We've seen the problems with this in trying to get separate compilation for templates in the first time around in C++ 98. The template model was not simply just a few generics in a simple fashion. It actually changed the model of the language. If you've ever tried to debug templates, you will know that that is still not satisfactory in 2023 compared to, and certainly error reporting, because it still, most compiler models or mental models people have operate off the idea that it's just a procedural language and errors happen in one place. If there is a compilation error, it happens in one place. Now, what's this got to do with ABIs? Well, quite a lot, because the whole thing is, what do you need from the language? The original idea is, if I have a syntax error in a traditional procedural language, that syntax error is in one place. There is only one thing that could possibly be happening if you're calling something. You are calling a function. In C++, you could be doing any number of things. The language has built on top of this very rudimentary, simple idea. And what it needs, and particularly when we start including a proper discussion of things like modules, proper discussion of dynamic linking, a proper discussion of some of the things that we want. And one of those things when people say, if we design this from scratch, if we designed it again, we'd do it differently. The gap between what is available now and what the language wants to be. I mean, C has not moved very far from its starting point in this. I think we have to have some kind of breakage. I think it has to be. I think we have to have a, for the various platforms, a version 1 and a version 2, as simple as that, or an idea of ABI evolution. But I don't think, I think the fact that ABIs are non-standard, or rather are set by a particular historical precedent, and don't mix well and can't evolve, is going to stand in the way of a language that is supposed to be a systems language. That's its origin. It's a systems language. It's supposed to be portable. And that used to just mean source code portability. We don't live in that world anymore. And so there has to be, I think, I don't think C++ is going to disappear overnight. That's not going to happen. But when people start saying, we could do a better job at this level, and they choose another language, then that obviously will push it down a bit. So I think there has to be that, if it's going to be serious about being a systems language that people can use for what we mean by modern portability or modern architectures. And avoiding the ABI question is not helping C++.
I do think we need to address that. And there was a very interesting paper coming up with a standard way to address that, that you could define code blocks as interfaces, and then basically say this code block is valid from either you could use a standard version, like this code block is only valid for C++ 23 and beyond, or you could like define your own versioning. Like if you're like a library and you want to say this code block is for version 2, for version 1.1, and that way you would be able to compile down the same code base into different versions and have like kind of everybody be happy. And I think that would be something interesting to have in the library.
I think that has to be the way of it, because we've seen the language, since the language has evolved, the hardware architectures and operating systems we work on have evolved. What we mean by modern software architecture has evolved, but if the ABI doesn't move, that becomes ultimately a bottleneck and you end up with an ABI that consists of workworkarounds.
That's already
to think of it.
Yes,
that's it. That's how it is.
It's not theoretical what we're talking about. It's just if you're worried about like caching effects, shared mutex on Windows is smaller than the normal mutex, because the normal mutex still had in its original implementation, and it's stuck in this ABI forever, supporting Windows XP, and it could be a lot smaller. And on Linux with GCC, it's a lot smaller. But on Windows, the shared mutex is in the memory footprint a lot smaller than the standard mutex, and stuff like that is.
So we end up being stuck with experiments of the past. We prevented evolution and therefore prevented improvement, even though everything else around it is improving. The underlying platform could do better. There are compilers that could, if we broke that, you could do everything better. So I think perhaps a different way of answering the question is, do you think there'll be an ABI break in the future? I think let's look at it from a different point of view. It's like kind of yes, but also I think we need to approach it philosophically. I don't think breaking one and then moving to another is the answer. We should learn the lesson of like, oh, it's always going to change. That's the lesson. It's always going to change. How do we accommodate change? And that idea of being able to target things differently, I think, is incredibly important, because change is one of the few things that is normal. And we now know this is a thing. We should accommodate that.
So there's a question which is, I'm not sure if you like familiar with EPOS and Rust, but someone asked, like, do you think a second attempt at EPOS, which also has been an earlier paper for adding this to C++, or something similar might stand a greater chance of adoption? How much would you go about that? Or how would you go about that? Not how much.
So I'm not as familiar with the Rust thing. So I presume when we're talking epochs, we are talking time.
Okay, so that's maybe also a fair disclaimer. At least as far as I know, maybe that's a good question to ask you. Are you part, or have you been part of the standard committee?
Yes, I have. Yeah, and normally I'm on it at the moment, but since the pandemic, I have had slightly less involvement. I got re-involved just before the pandemic or during the pandemic, but I've kind of work has taken me down a different path. So I don't fully know what is up with time. I know that one thing is that if we are talking about time and
no, this is about ABIs still.
So, it is. Okay, no, in which case I can't offer you a meaningful opinion, so apologies about that.
So let's move to the next question. Actually, we're gonna change completely topic. Would there be any plan to curate and release the 97 things every C++ programmer should know?
Very good question. As I have, so yeah, I did 97 things every programmer should know a number of years ago. That series kind of grown. We have everything from every 97 things every engineering manager should know. With Trisha G from JetBrains, I co-edited 97 things every Java programmer should know. And we did that at a point where O'Reilly was very interested in getting back into the Java market. And we looked at what languages were of interest, and we could drive this through. And the other candidates, I had a few other candidates, but they weren't as interested in C++. They weren't as interested in C#, which are the two other candidates I thought might be obvious. After the success of 97 Things Java, someone else did follow up and contacted me and say, hey, what about a C++ one? I said, yeah, I'd be absolutely up for that, although I'd be very careful if I getting involved as an editor. There's a certain amount of work in that. But at that point, and this would be 2 years ago, maybe even 3 years ago, O'Reilly said no. So I don't know if that's changed because the books have become more successful again. They kind of restarted the series in 2019, 2020, and that it has become more popular. I would be very interested in it. I'm partly interested in potentially, somebody said would they want me as an editor because I had experience with the two previous ones. I would also be interested in that because I think there's certainly a lot to say. But at the moment, I'm not the person to drive it, and I don't know if there are anybody else is trying to do it, and if there is interest yet. I think there would be from the C++ community, but I don't know if there is interest from the publisher.
And would you be able to publish this with a different company?
Potentially. I don't think it's. I think they would be looking for. I think it would not be so much a case of the subject as can you put a good case together for it, and I think it could be done. But if you start doing that with another company, I don't think there's any direct conflict intellectual property wise, although it might be a little bit confusing. So that might work against it rather than for it. It's difficult to know. But if I woke up one morning and I said, this is something I want to do, I would knock on the door of O'Reilly first of all, because I've had the two previous ones done with them.
All right. There we are at debating other languages. A question from LinkedIn. How do you see the Lang penetration in the market as Rust and other languages are on the rise?
Okay, this is an interesting one because languages move slowly. I had a look at in a couple of talks last year. I went through. Let me think. I went through a listing of what were the top programming languages, and I took three different different surveys. The TIOBE one, the Red Monk one, and then IEEE Software had a survey. And it's very informal in the sense they all use different criteria. And I wasn't interested in what is the perfect absolute, because there's a lot of different ways of asking that question. But simply just looking at the languages and saying, okay, which are the languages that have ranked in the top 20 of any of these? So I basically took all the top 20s, merged it, eliminated duplicates, eliminate and merge certain categories. Am I going to make a distinction between classic, Visual Basic and Visual Basic? No, I'm not. Eliminate categories such as assembler, because assembler is not a language, it's a language class. And go through and just basically tidy stuff up. And then look simply, just do a simple analysis. Which languages have appeared in any of the top 10s? Not which is the 10th, but which have appeared in any of the top 10s. But the other analysis that I did was go through them and say, what decade was this language invented? In what decade does this language come from? And in the top 10, if I recall from last year, I'm going to have to do this one from memory. There were most of the languages were from the 1990s or before. The languages of the 21st century barely made an impression on the top 10. They're in the top 20, but even said, you look at it and you're going, oh, this is the past. So Rust is making an impression, but it's hovering outside that top 10 mark. For some it's slightly in, for some it's slightly out. Languages are a lot older than the software architectures and products that we use. They move much more slowly. They move at continental speeds. Python often comes out number one. That's a baby of the 1990s. Its first official release was 1990. JavaScript is 1995, 96. We have all of these various things. And so C++ is, I'm going to go with that as the 1980s. I'm not going to talk about its prehistory. C++ is top 5 and will remain so for a very long time. But if there is a sudden uptake, if Microsoft for example, fully got behind Rust and started, and we've seen Rust is now appearing in the Linux kernel, if that becomes a particularly critical movement, then we may see an effect on C++ at that point. I think it's going to cause a little bit of shift in the next, let's talk about short time scales. In the next year or two, very small shifts. The next 5 years, I think that's going to tell us something. The next 10 years, then we know what has happened in this space, the space of this whole space of ABIs, of large companies that are responsible for platforms, large companies and organizations that are responsible for platforms. It's platform advocacy that normally will shift something this big. We've seen that, for example, with Swift. Objective-C has just dropped like a stone. Okay, the only people using Objective-C were people working on Apple platforms. Swift is now kind of is now taking its place. It's not a top 10 language, but it has moved very fast for a very short distance in time.
There's still a lot of people doing MFC.
Oh yeah, no, that's the thing, is there's a huge installed base. That's why the stuff remains in the. That's why it's not going to move. But that's what I mean. The point is, what are we going to end? Are we going to end up? Is the question here? Is C++ becoming Fortran, or is it still playing with the? Is it still? That's for MFC. True. That's my view in that sense. If you're working with MFC, you are basically working with pre-standard C++. Okay, and there's a lot of that out there. That constitutes a very if you like, I think sometimes when we look at C++, we have to, and particularly if we're interested in C++ and follow the things that the committee are doing, or actively go to C++ conferences, you may get the impression that everybody's using loads of cool stuff and is like up to date with C++ 20. No, the number of people using anything C++ 11 onwards is less than the majority. Okay, it is a minority of people that use anything post C++ 11. The dark matter of the C++ universe that actually shapes the employment, a lot of the employment numbers and a lot of the numbers of code bases is this stuff that is a lot of is much older. So yeah, that's not going to move fast. That's why this stuff sticks around. But the question is, if the new stuff doesn't get created in this, that's why I say the 1 year, 5 year, 10 year. If the platforms throw support behind other languages as well and explicitly start favoring them, then that's where the new stuff is going to shift. And what you will find is that, yeah, the legacy won't go away. The stuff we're producing today becomes the new legacy, but then that starts drying up and it slowly but surely moves out. Fortran is just outside the top 20, for example, when it comes to programming languages, but it's still in the top 30. So, that becomes the C++ of the future. Potentially, it depends. So I can't predict the future, but I do think there is increasing language penetration when people start making concrete decisions and discussions about, I'm going to do native code. I am new to software development. I've just graduated. What should I be looking at? There's a very strong incentive for people potentially to take up Rust or other languages that are coming down the line in 5 years. There's a strong incentive. Whether there's enough push behind that to really push people is another question.
I'd like to comment on that point, actually. Bjarne said something, I want to mention that context, very interesting. I think it was last year or 2 years ago. I think it was the AMA we did last year with him. And he is someone who does not want to, is often getting asked opinions on other questions and on languages, and he's always blocking it and saying, I'm not answering the question what I think about programming language X. But he then continued on and said, but what I can say is that those communities of those new languages are very self-selective, because you only get the best people, you only get the good programmers at the beginning, but it takes a lot more to shift the other 80%. And Rust might have the problem that they are now getting big enough to not having the advantage of being small anymore. Those are basically some of the design issues they want to address. There has been also some ongoing, I don't want to say issues, but I saw the generic code is based on macros, and replacing that might not be going as well in a big community now as it would be going with a small community. And various other issues which show up when you grow into a certain size, be it socially, be it economically, be in the all the other factors which do not play a role when you think about a programming language and being fast on the or safe or secure, and those things are coming along, and plus that C++ has an active standardization.
Yes, I think it's important to understand that there are these
features.
Scale points in terms of community and wider reach. But I think that the way that languages are developed now, C++ is definitely a language of the past. People don't go to a standards committee and say, we're going to develop a language. That's very much what we find with something like the Rust Foundation, is they're much more complete. And they have a very particular culture, and they are solving a full vertical slice problem. What is C++ packaging? Is there a standard way to do that? Absolutely not. In Rust, there is. So that's the idea. Is if we look at all the new languages, or the relatively new languages, you see a very different model, and they often have communities around them. Now, although I've used the term C++ community, there isn't really such a thing. There's a core C++ community that is basically has the standard as its nucleus and has people around that. I mean, you mentioned the Boost library earlier on. The Boost libraries were set up by people from the standards committee, and it's always had an intimate relationship with the standard. But what you find is that much of the discussion is around the standard, and that can benefit it. But the danger is to realize most people don't actually know anything about that. I would say 95% of C++ developers aren't even close to being what we would call the C++ community. And that becomes a different dynamic. So, it's a luxury of size, but it is also that issue. It's like when you're trying to, so the Rust, as anything gets bigger, the front and the back move further apart. And I think that the folks in Rust are discovering this. But the difference between the front and the back of C++ is off this screen. there are people still programming in 1990 when it comes to C++, but there are also people who are just pushing the edge of 23.
We do actually have a question from LinkedIn, like pointing in this direction. Like we see features at the C++ standard are deprecated at the next standard, which I do want to point that out. That is not true, because we introduced the deprecation feature, but we got very, very careful with actually using it. So we have deprecated some things, but as far as I'm aware, the committee is not deprecating things which are in the language anymore that often. So
it doesn't happen. There was a kind of a little flurry. There was a very kind of the language has gone through different phases. It's very interesting what it's prepared to add, what it's not prepared to add. So in the 1990s, we had this kind of idea of you do not add keywords. Oh, we don't add keywords. That was and then, let's add a few keywords just in time for 98. So in other words, let's do this one. Bool, that was a biggie. WCharT, of all the names we could have chosen, what a terrible name. I had a counter proposal called Longchar, which was much more logical. And then suddenly, let's throw all these other things in, like static cast iron. So suddenly there was a bit of keyword creation, but it was still quite modest. We were still recycling a lot of keywords. And that was visible as we went into C++ 11. Auto got recycled and a few other things. But we've also seen lots of other keywords being added, sometimes contextual, override, and so on. Getting rid of stuff, a lot of stuff was deprecated and not removed. And then just around 11 to, I think, probably 20, there was a lot of stuff did actually get removed. Library, and when I say lot, it's a relative amount, but things got removed from the library, things got removed from the language, got repurposed. But I don't think there's much else that people are removing. There is a deprecation. So deprecation is a concept, but I think it's kind of holding back a little bit. It's more library now than language. But I think the rest of the question is, why is there no clear architecture for C++? Yes, let's talk about that from another point of view. Is there a vision for it? And I think people have tried. There are, I can see this on the standards reflector, trying to basically say, here's what we're going to focus on. But because it's a very decentralized structure, the committee is lots of subcommittees, lots of interest groups. There isn't a single driving individual or concept of the C++ direction board that drives that. Going back to how other languages have evolved, they've grown from a very different source. They have not grown in the way that C or C++ grew, not the way that Fortran. These are the classic languages that underwent standardization through an ISO or other national route. Other languages have taken a very different path. They've either had a company at the center or some kind of open foundation, or they have grown out of open source. So their whole organization of people and what they are trying to do is very, very different. And because particularly the ones that have come out of open source software development, they look like software development projects. And what do you have on a software development project? You have to have a vision. So it's grown out of that, and you build it. The C++ committee is not about implementing in the next reference compiler. That doesn't exist. Whereas what we find is there is normally the standard So in other words, C++ standardization is not run as a software project. It's not run like that. So it doesn't reflect that. These others have grown out of that, which means they tend to have a much clearer vision of what direction they're going to take and what they're going to do. Whereas if we look at what gets added to C++ in each version, it feels like lots of different parts. Some of these are really good, but they often feel a little bit incomplete. There's not an overall. So, for example, modules got added, and the C++ library was not modularized. Okay, why would you add a feature that you're not going to use?
Well, you need to have that's kind of a chicken and egg problem.
Potentially, but that's the thing, is there's an experience thing.
The library actually is coming. And I've heard that maybe C++ will be actually a topic which people actually already start like using and speaking about. But on the other hand, the standardization process is like we're creating a receipt, right? This is a standard. It's a purely theoretical document, and this staying with receipts. you can choose from 3 different main chains where you want to eat this recipe, right? You go there and they cook it up and you get the lasagna, and every one of those has their own flavor. And there's like people which say, well, I only go to that branch and this is the best one. And then there's, other people also serving you standard C++ in their version, in their compilers, with GCC, MSVC, and Clang being the main branches of us. And that's very unique to have multiple vendors. And
it is, yeah.
They're part of the standardization process, but the result of the standardization process is not their compilers. It's a document.
Yeah, it's a document. But importantly, let's go back to that vision. Let's look at the. I'm going to call it the failure of modules. I know that people are doing talks about it. They were added in C++20. The number of people actually using them is minimal. At this point, we have minimal experience. Is the C++ standard library modularized? Well, that's not going to happen for another 3 years. So there's going to be a 6-year gap between introducing a feature and actually using it in the standard itself. There's a whole idea of dog fooding. Likewise, concepts introduced, the library was not standard. They were not used in the library. Now, that's because these come from, this is a perfect example of Conway's law. Something's added as a core language feature. The library people don't use it. C++ is not, so in other words, C++ would probably have more of a coherent vision if it were its own consumer. Now, when you look at how this, we can look at other languages, for example, Java, when it added modules, it did not add modules until it could modularize itself. When it added streams to kind of like the ranges kind of equivalent, they did not add all of that until they were able to integrate it fully in the library. So in other words, it was language and library. And that, again, I'm going to go back to that idea of like this idea of the foundation or the community in terms of an open source community reflects a very different vision, whereas C++ does operate as different subcommittees and different parts get added. So we often find a core language thing, look, that looks really cool, but then it's not used in the language itself. Coroutines were added as kind of like IKEA furniture, and only recently the basic bits and pieces being added that allow you to use them easily, but they're still not integrated in the library. So there is this problem of we talk about, oh, we should have user experience. Well, we can offer people actual experience by integrating it ourselves. People don't want to try it out if it feels theoretical. And I think that is the issue. The minute you start actually using something in the language or in the library that uses a feature in the language that is new, of course you're going to follow on using that. But if somebody just tells you, hey, there's a thing in the language, it doesn't integrate with anything else that you're doing, what is my incentive? Unless I'm really interested in just adopting that, the majority of developers are not going to use it. And that is a problem because there's a feedback cycle here. It means that we don't get the benefit of having perhaps that vision. So yeah, I think it's a really interesting question. There's no easy fix to it because it's a path dependency. It's a historical thing. We're here because we're here because we were there before. And these other languages and environments and cultures have grown very, very differently.
On the other hand, I'm very happy that the C++ standardization takes its time. And, having a feature available in 6 years that was considered fast at one point in standardization, right? When C++ 11 came out, you expected it to be the standard of the decade and not like for 3 years. So
yes, I am very pleased that we're now operating on something a little bit closer to internet time. I think that feels a little more reasonable. And it also allows the committee to adjust, because the original vision was there were going to be alternating, the 3-year cycle was going to be an alternating cycle. In other words, after C++ 11, C++ 14 was going to be small, 17 was going to be big, 20 was going to be small, 20. They're kind of, actually, it's just like, no, that doesn't make any sense. We don't need that alternation. So it's a steady flow. So I think that is certainly welcome. But I think we can still do better. And I think that might be a matter of kind of, changing the lines of communication within the community and say, well, if this feature is so useful in the core language, why are the library people not using it? That split between core and library is a very long-standing one.
Okay, and now to something completely different. Given your various interests in languages, science, and mathematics, Which 4 famous people, living or dead, would you invite to dinner and why?
Oh, okay, that's a really good one. Okay, so okay, let's start off with mathematics, because let's start off with mathematics. Pierre de Fermat, I would like to have dinner with him and really ask him, what did you actually write down when you wrote that thing in the margin? And you said that you had this elegant proof. What did you have in mind so that we could actually find out if the 1,000 pages of Andrews-Wiles proof is necessary? If Fermat did actually have deeper insight that we have been unable to recover, or if he just made an error. I think that would be interesting. I think Richard Feynman, the physicist Richard Feynman, I would enjoy. I would really like to meet him. Obviously via a time machine. I use a number of his quotes. I find a lot of his thinking very fresh and inspirational. I mean, he's not a perfect individual, but he has a very practical relationship to knowledge, and yet he also draws on an immense amount of theory. But he makes his approach to science is engaging. It is playful, but he's not superficial. I think that for me, I think that'd be absolutely fascinating. In terms of, I think in terms of language, I think a really interesting one. I'm going to pick somebody who's alive. So from a linguistics point of view, Noam Chomsky, who's still alive. I would like to talk to him, but perhaps I would like to talk to a past version of him. Because he had some particular theories about language, and I read his stuff that gave us the whole idea of context-free grammars, regular expressions, all this kind of stuff. I think that would be really, really interesting to really find out the other side of it and where he's coming from, because he presented it in a very academic way, and he's got a lot on a lot of subjects to offer. So I'd take him present or past, but I think a past version of him could be quite interesting. And I think we'd also. I'm going to go for a computer scientist as my last one, and Barbara Liskov. I've followed her work for many years. She is still alive, but I followed her work for many years. I've managed to accidentally avoid everywhere she's ever spoken. She is perhaps a little old now to be traveling and doing talks, but her contributions to distributed programming, our concept of types, type systems, modular systems, paradigms, language design, all of this stuff, I think her work has been immense, not just in the 1970s, but the influence that it's had. I think that would be really, she'd be somebody to meet if I could possibly afford to. But, yeah, great questions. Great question, that one.
Okay. Let's ask you about testing. Regarding unit tests, what is your take on writing mocks versus calling real code in unit tests? There are some debate about over mocking, I heard.
Right. Yeah, I think we need to. There's a lot going on here, and I'll take out the separate things to give you a sort of a sensible answer. The original vision of mocks was to help you design interfaces. That was the original idea. Most people are not aware of that, and they don't use it like that. They use mocks as, oh my goodness, I've got an external dependency, I need to block it out, or I've got some kind of slow dependency on the database, I must mock it out. That's how a lot of people think. They think mocks is a way of dealing with a dependency mess. It's like, no. The whole purpose of mocks was so you didn't have a dependency mess. It was to cause you to design. The idea of using the mock from a test-driven perspective is you learn what interface you need. You don't, somebody doesn't come along and say, hey, I've got this code, you can use it, and you use it. You don't do that. What you do is you say, my application needs this functionality. You're offering me this much functionality. I don't need that much, and it's not the right shape for my application. So it's a good implementation, but let me write the interface that I want, so I might adapt it. So what you're doing is you're inverting the dependency. You're inverting the way you think about interfaces. You take it from the consumer perspective. I'm a piece of code. I would like some facility. What should that facility look like to make my code easy? Yeah. So from that point of view, I think mocking would be great, and I wish more people would do it. I wish people would do that original philosophy of mock-driven design, because our APIs would be smaller, our classes would be smaller, everything would be smaller, and the dependencies would be much better managed. So that's the first point is, I wish people would do that. The next thing is when it comes to, but for me, the most obvious boundaries when I talk about mocking and when I introduce mocking, it is to do with the most, when people are saying, well, where do I define the seams where I should or should not be mocking? I tend to come back to a very simple definition and unit tests. What do we mean by unit test? And for me, a unit test is something that is isolated from external dependencies. And therefore, put it another way, a unit test, the outcome of a unit test is based on the code of the test and the code that is being tested. That's it. If it passes, it's because of this code. If it fails, it's because of this code. Okay, that's it. There's nothing else. And that's a unit test. What if I am testing with a file system? Well, I can have perfectly correct code and a perfectly correct test, but I might have the wrong permissions. The files might be full. Hey, well, let's refer back to Toyota. I can have perfectly correct code and perfectly correct tests, and my test can fail. In other words, it's not showing me there's a problem with my code. It's showing me there's a problem with the outside world. What if I have code that seems to work in the presence of threads, and then one day it doesn't work in the presence of threads? The only reason it was working, it was actually broken all that time. The only reason it appeared to work was because of something external to my code, the scheduling policies of the operating system. So basically, if you're dealing with anything where the correctness of the outcome is not based on the code that you're looking at, then that's not a unit test. And that doesn't mean, I'm not saying it's bad, I'm just telling you it's not a unit test. It's not fully isolatable. So from my point of view is, you want to get as much, and sometimes we will then talk about these isolated aspects. We will need to actively isolate them, and there will be something we call. What's on the other side of that? Well, for testing purposes, how do I do it unless I use a mock? Okay, so therefore I would be using it in that case. I wouldn't be using the real code as a unit test. I'd be using that as an integration test, and but my integration test would be a lot simpler. And also, my unit test is going to be a lot faster. And my overall design, a lot more loosely coupled, a lot better separation of concerns. So that's the way I approach this one. What about the problem of over-mocking? The problem of over-mocking tends to come from when we see a bunch of code and we say, oh, here is the code. And in our head, we think, I can't change the code, but I need to test it. And maybe that's just in our head. Maybe it's actually a reality of the choices that have been made that we have not made and cannot change. At that point, you end up with a code that's already a mess of dependencies, and you do end up with over-mocking because you have mocks returning mocks returning mocks. It's very complicated. If you were to design it from the beginning, you would say, no, we don't need this tangle. This one idea should become two. It's two separate ideas, separation of concerns, which would lead to separation of dependencies and so on. So yeah, over-mocking, that's one source of over-mocking. The other source is where people start testing implementation details rather than interface details or semantic details. And that's a very common thing because historically another term for mock testing was endo testing. We don't use that term anymore, but it's testing from the inside. It's like you're testing callbacks. You're expecting certain things. And that becomes very tightly coupled to an implementation. If you change that, then you've over-specified it and you've broken it. So that's kind of where I sit on this. I don't think it's an easy decision. It's not a 1 or a 0 or a black or a white. But I do see a lot of tendencies that lead to over-mocking. Test with real code as long as it's within your control. Don't factor out testing. I've seen people actually sort of say, oh, I'm going to mock out the container that I'm using as my private representation. No, that is absolutely not the way to think about it. That container is private. It's private for a reason. It's an implementation detail. but your interaction with emitting events to something else that receives events, that's an external detail that deserves to be mocked. So I hope that covers quite a lot. I'd always spend a few days talking about this, but yeah, hopefully that's given you a reasonable idea and a reasonable answer.
Yeah, I think. Let's see. There's a question on parallelism. I'm not sure if that's like a specialty. What do you think about C++ usability in connection with concurrency and parallelism in general, or in comparison with other languages? Do you see any missing features what should be definitely added?
Yeah. Okay. So my background with this stuff goes back a long way. I'm not going to say I'm totally up to speed with everything that everybody's doing these days, but I originally got a master's degree in parallel computer systems. And one of the things that on that, I studied CSP, communicating sequential processes, which was the basis for the Occam language. And the Occam language has channels, which Go sort of has a bit of a go at. And I also studied, my thesis was on the actor model. And these are very clean models of expressing concurrency constructs. And by the way, I'm just going to use concurrency generally to refer to anything where there is potentially simultaneous activity. I'm not going to try and say that concurrency and parallelism are two different categories. They're not. They kind of, depending on how you define them, they either overlap, subset each other, or whatever. I'm going to use concurrency to refer to all of these. I feel that C++ is not as usable as it could be. It started, there was a thing, we first got proper standard threads in C++ 11. That's a long time after people wanted a standard solution, but as the standard was deferred, it was kind of inevitable. C++ has to have a threading model if it's to be a credible language for systems programming. You cannot say, I am a systems programming language, but I can't talk at the level of the operating system thread. Then you're not a systems programming language. Okay, so you have to have that level. I'm not going to say you don't want it, but the first thing we need to recognize with threads is that they are very raw. They are a primitive. And
yeah, they are a thread.
Yeah, they really are. Here is a thread of control, and here's locks. Good. It's this is. I mentioned IKEA furniture. This is probably more IKEA furniture in this sense. It's like you have to build this. You have to build up your own construct yourself. In other words, before you can actually be producing useful code, you've got to choose your paradigm and your whole approach to threads. People are not aware that this is a decision they can take. So they often end up programming at the level of threads. Oh, look, I have a function here. Let me just launch it as a thread. Oh, my goodness, we're going to need to lock this. And we're going to have to lock that. And it's basically like trying to put out fires. I'm really sorry. I have no idea what that outage was. I've just checked everything. I have no idea what that. Yes, if you've got a nice screenshot of me just freezing. Yeah. Okay. So, where were we? So the thing is, this idea of building up primitives, we could just say, just like, a jump statement, a go-to is a primitive. From a primitive, you can build if statements, while statements, and all the rest of these other constructs. And we would much rather use the built up things than have to rebuild it ourselves. Having programmed in assembler, but also programmed in old Fortran, the idea of making my own while loop has very little attraction. But that doesn't stop people working at that level. So a lot of people are working at the raw level, which is not usable. It's error prone. Unless you go at it with a clear abstraction, then just adding threads is a recipe for a mess, and it won't give you performance benefits necessarily. So what you're kind of expecting the evolution of the language is that you rise through the levels, unless your claim is we are a high-level programming language just targeted to make all concurrency approaches easy, or the main concurrency approach is easy, and to be very opinionated about it. This is what Occam did. In Occam, you only had channels. There was nothing else you could do. And it was very opinionated. You could not share data between running processes if the data was mutable. The only way you could share data with another running process, i.e. another running thread, is by passing it through a channel. And the compiler would stop you if you tried to do anything else. It was a massively opinionated language. But the thing is, if your code compiled, it probably ran. C++ as a systems programming language doesn't come from that tradition, but it also hasn't really risen through the levels. I remember at the time we were working on the memory model in the mid to late 2000s. I kind of considered that to be a level 0. You've got to get the memory model right. And then on top of that, you can build the kind of primitive construct, the go-to, which is thread.
Which is something we have. We have a memory model.
Yeah, we have that. The next level, what I called at the time level 2, is where you get people away from using that. In other words, these are available for you, but then we have much more, and we have a much richer vocabulary. We're kind of getting that a little bit, but it's been a long time coming. It was, and I wanted it to be there in the beginning. Proper use futures, asynchronicity. These constructs that basically mean you will not have people passing pointers to shared state between. That has been very slow in coming. And my original hope was that was all going to be present originally. I even had a threading proposal in the mid 2000s, which was future based and took the idea of threads and said, let's make this a function based concept. And not the way that it is now. It was much richer. It was a higher level approach. I mean, I'd still make it even more high level, but it was based on the idea of fully asynchronous execution, passing futures around with a possibility of doing channels. And that is not the path that we have taken. So I think from the C++ perspective, C++ is very capable. It allows us a lot of this access, but it has not added the higher level constructs at the right rate in a way that makes people's lives easier. And so therefore, I would say the higher level constructs, that's what I would like to see. I would like to basically have it so that people are not sitting there worrying about thread pools and stuff like that, and basically saying, I just need this executed asynchronously, and here's the channels we're sharing. And this is a long way beyond async as it stood. Proper continuation model, all of this kind of stuff. That would have made, I think, C++ a much more different language to program in from a kind of concurrency perspective.
I'm actually kind of happy that we didn't try to standardize the C++ 11 perspective on this, because we probably wouldn't have had the needed representation in the committee from other sources of concurrency with GPUs, etc.
And that's and I think you're right there, because there's a whole load of other stuff there as well.
We're aiming exactly at that, at having a framework which does concurrency and parallelism with algorithms and everything in the C++ world, but which just not says, well, that's threads, of course, but you can have, of course, other concurrency targets.
Yeah, a lot of the parallelism stuff again has come from a different route, and you can look at you look at the parallelism stuff, you look at the threading stuff. The parallel algorithms look very different. They feel very different. I don't think they're mutually exclusive, but they're not. They don't spring from the same source. But in terms of kind of like more classic MIMD, multiple instruction, multiple data. I do wish it had been more opinionated. I do wish there had been more high-level stuff. I would have gone for something based. My personal preference is for futures and channels. That's what that's the kind of way I tend to think, and I found that's a very useful way of working. And that could have been in there from the beginning, but it wasn't. And we are making up time slowly with that. I remember at the time there were a lot of exciting ideas and possibilities. I remember Herb had a whole load that would have been really cool for composition. In other words, really to try and think about this in terms of composability. Threads and mutexes on their own are not composable. And this whole idea of being able to just bind things together in a very natural way with with a very high sense of comfort and safety. That's what we kind of that's what we should have. Threading is unnecessarily hard. The way that we've the C legacy and the C++ legacy of how we think about threading has made it unnecessarily hard, I feel.
Indeed. We talked about GPUs and parallelism and concurrency. We have a question about AI. Is there any effort on making C++ competitive for data processing angle where it stays closely relevant on AI ML pipelines?
I'm not specifically aware of this. I mean, we normally tend to think of it from that point of view, is that C++ forms part of the story. In other words, it's the language of choice for number crunching in a lot of places. And when thinking about it from that point of view, then it's kind of there. But in terms of anything else, I don't really know that there's any kind of move toward that. I don't think that anybody is really kind of saying here is a standard way in which we should be creating frameworks in C++ that support a machine learning approach, and looking at it from that point of view. To make it competitive, I don't know. That's really more, I think that's an open source question from that point of view, and there's probably no shortage of things going on out there. But normally the way that C++ is presented, I think it's a different thing. So we often see this. We'll write the algorithms in C++, but we'll present it through Python as being a kind of classic example, TensorFlow. And that, as opposed to, yes, our pipeline should naturally include C++ all the way through. I don't think that's a thing. I'm going to say, I don't think that's a modern architecture. I don't think that's the way people want to go. A lot of this stuff will have a particular server structure and a front-end approach. If you're going to build a whole system, you're going to end up with a multi-language model anyway. You won't glue a pipeline together using C++. That would not be the natural choice. You're likely to use other means. So I tend to feel that it's
are available on C++. Okay, so
yeah, these are all there, but
that, and then there's the Python interface, and I think historically a lot of the usage came from scientific purposes first, and other areas where Python plays a role, startups, etc. And so Python is ahead of that, and is probably like the language, and some new language called Mojo being introduced because it's faster and compatible. So we'll see where this goes. On the other hand, AI is such a hype that we don't know where it goes and what it does. So
I think that's a very important point, because today's whatever is going on into a large language model pipeline is going to look very different to that's not the whole of AI. I mean, it's that's the Chat GPT, that's the headline, that's the kind of and then there's a whole lot of other stuff where we talk about generative AI in general. This is a broader area that takes us into stable diffusion and all the rest of it, but that's not all of AI. There's a whole lot more there, and we find that it's a very diverse space. So I don't know where we would see, but I think C++ is often going to be part of the solution, but I don't think it's going to bind and create the whole solution.
What is your advice regarding what all areas mid/senior experienced software engineers should learn and know other than programming language expertise?
Yeah, good question. Let's go back to this point that a number of points, a couple of points actually specifically. Jens and I have sort of said, there's the language, and then there's a thing outside. There's the people outside. There's the community. There's the stuff there. But I've also referred to ecosystems and the things around the languages. So therefore, it is understanding programming language expertise. The programming language that you are working in, if that the primary language is C++, then obviously having skills in that and improving your skills in that, that's great. But also, what are the secondary languages that you use? Pay attention to those. We have a real habit, particularly in environments where we're not naturally using lots of languages, to treat these secondary languages as somehow very secondary. Give them a bit of space. You'll be surprised. We mentioned Python. I kind of turn up sometimes to C++ places, say, okay, what's everybody's second language? Hands go up. It's Python. It's kind of everybody's favorite second language. But only a few people really have grasped it and fully understood it. And they would probably write far better Python code and even better C++ code. I know one place back when after C++ 11 was introduced, that their goal was to send people on Python courses so they would write better C++ 11. That idea, so even within the programming language space, that idea of work with something else and get good at those other things that you think are the edge of what you do, bring them into the center. But again, that's still not the whole picture. Beyond programming language expertise, understand things about architecture. It's very easy to get drawn into the syntax and the current class you're working on or the current cluster of classes. what about the bigger picture? What about the nature of change with time? Code analytics, things like that. Adam Thornhill's book, Your Code as a Crime Scene, where you're really trying to understand the system. How does the system of code behave over time? In other words, who works on it? What things change together? This is a far deeper approach. It's the difference between looking out of your window and working out the weather and what you should wear when you go out the front door versus having a high level view of watching the weather patterns moving across your region of the country or the world and recognizing, oh yeah, it's all connected. So a bigger architectural view, I think, and there's a lot to software architecture. So I would definitely say that is an area, particularly if your job as a senior, that is one of the things you want to offer people, is not simply I know more stuff about the language, but I also see where it fits, and you're offering a larger view. But in other cases, the learning can be kind of, and I can sort of say there's a lot of tooling kind of stuff and probably learns things that are outside your, programming language you're not using and not even as a secondary language. Go and have a look at it if it's different. I think there's a lot to be learned and enjoyed in doing this, and the same for other tools. And maybe you're excited by AI, but you're not working in it. Sure, that's fine. Go and work with it. Maybe you seem to think that AI is the whole universe and you are working in it. Well, go and look at something that's not that. Go and look at something else to give you a different perspective. But I think the thing that gives us the biggest perspective is the learn bit. I mean, people always call them soft skills, and there's a question of whether that is the right term. It seems to downgrade them a bit. But for me, it's the idea of building on that software architecture thing. The behavior of people creates the system. Mm-hmm. Software doesn't come by magic. It's how people interact. And you can kind of spot software that is created. And there are development cultures and organizational cultures that are very good and they create the right environment for that. And then there are ones that don't. And even though the engineers might be individually brilliant, what comes out is problematic, complex, broken. There's all kinds of different failure modes. So I think understand the people side a little bit more. And certainly at the senior level, the way that you do that is by doing coaching. You're senior, work with somebody who's not. Don't assume that they're going to pick up all your knowledge by osmosis simply because you're in the room. Don't assume that they need to follow necessarily the same path as you. Give them shortcuts. And they will also ask you questions that you will never have thought of. Because you have if you're senior, you have a historical way of learning, and it's very tempting to teach other people according to your history. Whereas people coming into things now, it's just like they don't need most of that, but they may also see it from a different perspective. They may ask a question that initially seems dumb, but is surprisingly hard to answer and gives you an insight. So yeah, it's very much that. Put yourself in a position where you are mentoring and coaching somebody else. You will learn a huge amount.
And I think that's also like a similar perspective I give people asking for job interviews, that even if you're a beginner, if you're just starting to like, you have 5 years in the industry, you've learned C++ and programming in a different way. You have skills and knowledge about systems which don't exist in the team you're hired for. So naturally, some of those skills could be really interesting to them because they're new and they lack those skills because they don't have someone who has experience with AI. That's like a whole different perspective, which a new person brings into a team. And so it's definitely important to, not only like hone your skills, which are needed for the job market, but also like hone those skills you're interested in and what you learned. And then that can be very interesting. And also can be a first job. I remember like asking the dumb question why we would be looking for a software that can validate if a link works or not, and why we wouldn't just write our own crawler, and all that software that was able to do that was very expensive. I was like, why do we pay like more than like it was like upper 5 figures or something, and like, do we have budget for that? It's like, that's a simple Java program it was back then to parse some HTML, get the links out, call them again and note that through. And for the department I worked in, that was like a little miracle to have someone write that within 2 weeks, to have a simple program which calls a page which is defined and then tests if every link on that page works.
Yeah.
And that was the whole thing. It was not like building a web crawler and getting all the information out of the web. No, it was just, are the links on this page still working? We have a portal and we would like to know, to test it every night. And
you come in with different assumptions. That's the key thing.
Yeah. So there's a module question. So let's go for that. Do you think modules will really help on reducing compilation time for huge code bases?
They should, because we're not having to reparse all the code. That's such a bottleneck. So yes, I do. I think the challenge, though, the challenge is huge code bases are typically historical and legacy. So the very target for modules, the very systems that would benefit. I mean, we can see any language that actually has a separated module system. And, I am old enough to remember Turbo Pascal. And one of the things that is absolutely miraculous about Turbo Pascal is how fast it compiles. I remember using Turbo Pascal. I remember thinking Turbo C++ was pretty fast. But Turbo Pascal was insanely fast because it had a separate module system. It did not have to go through all the headers again and again. Now, that was a long time ago. And all that has happened since then is that C++ systems have put more and more in the header and got more and more complex. And it's been a fight of hardware and a few compiler tricks to try and cause a speed up. But you're ultimately fighting a losing battle. In order to compile any source file, I suddenly have to do all of this stuff. And that leads to things like Unity builds and all kinds of workaround techniques that are effective, but they are workaround techniques. The problem is the huge code bases don't appear tomorrow. I mean, so today is Wednesday. Thursday will not suddenly see the creation of a new huge code base. That takes time. So the very target, the very systems that would benefit most from modules are the ones that are old and are the least likely to adopt modules. We have a paradox of adoption here because people are, it's legacy, we can't change it, works, we can't change it. That'll cause all kinds of interference and problems and so on, and potentially compatibility. So therefore, people play cautious and they won't modularize it. So yeah, I do, from a technical point of view, yes, they do. From a social and economic point of view, then there are different obstacles. We're actually answering a different question.
Well, what's your recommended approach for writing unit tests for an existing code base with already tangled dependencies?
Oh, there's no one approach. I tend to think of code in that situation. I talk about it as being the art of the possible. What is possible? Okay, let's not worry about ideal cases. Let's make that a destination, but that's not where we're at the moment. What is possible? If we already have a culture of integration tests, then my recommendation would be to continue working within that culture so that I can now then more safely refactor things so that I can then, the next generation, I am able to then introduce unit tests. The benefit of that goes all the way back to build times, but also you're ending up with something that is cleaner. You're ending up with something that is more modular, different use of the word modular, but more fine-grained. That this thing that shouldn't depend on a file, it should depend on data, not where the data comes from. I want to have that structure, but maybe I'm not going to make that change if I feel the code already works. Give me an integration test that demonstrates that, then I will change this code accordingly, refactor it, and now I can also write unit tests and probably move the bulk of the activity that goes on in the integration test into that, and it will also execute faster. Okay, so I still keep something of the integration test, but because we're always hitting secondary storage, it's going to be slower. So in other words, that would be one way. If you're working with integration tests already, work with the things that you've got. You've already got a setup, you've already got a culture with that. Look to make those better. In other cases, break the dependencies. How do we do that in a fashion that is safe if we don't have enough tests? this is what Michael Feathers called lean on the compiler. There are some changes that you can make that if you get them wrong, the compiler will tell you. Okay, these are not changes in logic. If I start refactoring logic and I don't have tests for it, the compiler won't object. But these are tests to do with type system. This is like where we talk about renaming and moving, splitting classes. If I try and call a function on a class and it is not on that class, the compiler's not going to go with it. It's going to tell me in no uncertain terms. So there's a class of refactorings that are about movement of code that if you get them wrong, it's the compiler that will do the checking. You're not actually changing the logic. Okay, so in other words, work along those. That will be different for different languages, but in C++, we have a sufficiently static and checked type system that you can actually find a lot of cases where you can do that. And therefore, you open up a seam and a possibility and say, right, now I can drive a unit test in there and allow myself to do other changes. So that's kind of two approaches. Again, another approach is that you start spoofing things. So I make a slight distinction between mocking and spoofing. A lot of people don't. By spoofing, I mean is like I will substitute headers, okay? And I will say, here for the test, here's the actual header that you're going to be using in production. But I'm going to spoof this at the level. I'm going to make sure that the path is changed for my tests. And I will pick up something that provides mocks or other kinds of test double as appropriate. But I'm going to spoof that so that I haven't actually had to change the design or the dependency structure as it stands. But it can be very creative. Sometimes doing that, but that would be another technique. You can also consider link time spoofing as well. If you've got something that's binary compatible, do that. So, there's these different techniques. So, as I say, it's about the art of the possible. You have to kind of come to the code base and say, I have all of these possibilities of how I can work within it, and I will see what fits. This one, maybe this technique pushes this far. Another technique pushes another way. You treat it as a kind of more pincer style action. You treat it as a long-term progression. So yeah, I think that that's a case of building up a kind of like a kind of vocabulary of techniques to help you.
Okay. There's now two questions which I both want to read to you because they're basically almost the same thing, but one is coming from LinkedIn, the other one is from Hubido. What do you think about the use and role of AI in code development, especially in C++? And let me layer over LinkedIn. How do you see the future of tools and AI extensions which do generate the code and also programmers in the very long run?
Okay, yeah, this is an interesting topic and one that I managed to find a quote from myself in a talk I gave in Poland in 2016, where I was asked a very similar question. And obviously, the world in 2016. From the point of view of code-based generative AI is very different to the world in 2023. At that point, we were saying what might happen in the future. Well, now we're in the future. And my key observation was, you've still got a job. Well done. But you better be testing. You need to get better at asking questions. You need to get better at understanding what it is that you want. Your eye also needs to get better at being able to discriminate a good solution from a bad solution. Being able to generate code is wonderful at one level, except when it doesn't work. And you need to know that it doesn't work. And what we're going to find is that a lot of people are going to use AI related tools. They're going to use a lot of generative AI to generate code. And a lot of that code is going to be not quite right. And they won't know it because they won't test. In other words, what we're going to find is that in future, there will be the people that remember to test their code and already are good at testing, but they're also good at specifying their problem and immediately recognizing if what they're getting is not quite right. And then we're going to have a lot of people who are going to use this just like any other tool, and they're not going to do that. And they are going to create what we like to call legacy code, because it's legacy code because you didn't write it. It's written by somebody else. It doesn't quite work or doesn't quite do what you need it to do, but now you've got to fix it. And this often happens sometime, we push the code into production, but we didn't test. And now next week I've got to fix a problem, but I thought the code looked okay. And the problem is we're already seeing this happening, and we're seeing it happening in a number of cases. I think one of my favorite ones is Bertrand Meyer actually published an article earlier in the year where he talked about getting a solution from AI and to a very simple problem. And he said, it looks plausible in this, but there's a bug. And then he chose another solution. And he asked the question differently, and it generated, and he was satisfied with it. There's only one problem. It didn't work, but he didn't test. He just thought it looks and feels right, or it looks complicated enough that it's probably right. We have this little funny filter cut off.
You probably have mixed feelings about generating unit tests with AI, which I've seen as like
typically, because again, I tend to ask when I had an interesting experience. It wasn't with C++ earlier this year. I did some stuff with Kotlin, but I'm not a Kotlin programmer. But I thought, you know what, I'll ask ChatGPT. I've also since asked Bard, and it gave me a much more working solution at that point. But ChatGPT, I asked it the solution, and it gave me something that was idiomatic Kotlin. And it was absolutely brilliant. There's only one problem, is it completely hallucinated the functions that I needed. And then it eventually gave me a solution when I pointed this one out. And that solution, again, looked plausible, except for one thing. It didn't produce the right answer. Fortunately, I had tests to spot that. It did all the mechanics. It did all the movement. You had the loops and all the rest of it, but it didn't produce the right answer. And then the next time. So in other words, you need to consider, when you look at it from the point of view of AI, you need to consider there's a conversation. It's not generating code for you. It's not a straight through process. It's not a formal transformation. It's a conversation. What about this? What about that? Let me just check that for you. Okay, that's not quite what I was after. Or I'll take what you got and then I'll adapt it. But there's a human in the loop and there's tests in the loop. Now, when we start saying, let's generate unit tests for that, it's like, well, tell me what you mean by that. Are you going to tell me that you're going to get something to generate you both the code and from the same words and specifications, it's going to generate tests? Yeah, good luck with that. First of all, it's not going to run them. It's going to leave it to you because these are not running them. That's an important thing. That's a solvable problem, by the way. They can do that, and they can learn from that. But at the moment, that's not really what's happening. But there has to be something in the loop that asks the question a different way. And there has to be something that applies judgment and goes, oh, wait a minute, I understand the ambiguity in what I asked. The problem's with me, or actually the problem's with you, you're hallucinating. That's where the human is going to be important, because otherwise we're going to be generating code that other people wrote. We already have that problem. So in other words, we've already got that problem. The idea of multiplying it and creating a huge legacy debt is a problem. I'm perhaps a little more interested in seeing AI on the refactoring side. Take this code, refactor it into something cleaner, and then I already know what I'm expecting, and I can write the tests against that. And now we've got rid of the problem of legacy code. But if the problem that we have is if we start using AI to create new legacy code, I think, and there's a lot of people that are doing that and have done that and will do that, I think that's going to be a problem. Yeah, it's fast. It looks like you're getting results, but what's going to distinguish the top programmers from the rest is those are the top programmers who know what they want and know how to get it and know there's a dialogue, and they are going to they're going to get some really good stuff. So I think it's going to widen the gap, but in terms of software developers, in terms of potentially the skills or capabilities that people adopt.
I've seen your experiment with Kotlin, and it's rather interesting that basically, you get to the point where you have code that you can put on a slide, and most people in the audience will believe that Kevlin Henney or anyone else could present this slide, and people would read through it and say, "Oh, of course, that's how you do it in Kotlin." And then, well, actually, no, that's completely hallucinated. And I think that's a huge problem with which a lot of people still need to start understanding, that those systems are not truthful and do not have any idea of wrong or true or false.
They have I mean, there's a bigger discussion here, which I don't think we have the time for, but there's understanding what is the nature of such software, and that idea, I think, is going to be. I think there are certain things that can be improved and will improve, but there's also something else that is fundamentally missing. still requires a human in the loop. And I think that is going to be, you are left with the same problem. How do I specify what I want? Okay, that requires precision, and that is, sometimes people call that computational thinking. It's not about the curly brackets. It's about being able to say that I want this with this, and being absolutely precise, and then knowing what you've got. That there is a skill in that space. And if you don't have that, you're constantly going to be chasing broken things. You'll look very busy, and in some ways you might even look productive. But I think that there is there are going to be some issues with that. I would also be interested in the role of AI from the point of view. There was a question. The question was phrased also, by the way, with specifically with respect to C++. Let's go right back to where we started, and also talking about CPP2, the complexity of C++. What you kind of want is a static analysis, but at a richer level. Potentially, it's that, let me not just offer things to AI and say, hey, generate me this. I've got some C++. Can you see anything wrong with this? Or what are the potential memory issues here? Or these kinds of things. Tell me about this from a security point of view. Let's turn this around. And not think of it just as generator, but as reviewer. I think there's potential there. Okay. So I think there's a lot of things that it's very easy to fall into the generation idea as being of that's what we're going to get. It's like, actually, no, there's a number of issues with that, not all of which are going to be problems forever. There are still a number of issues, but maybe we're missing some of the point. Maybe there's a lot more that we can use, something that has been trained on a vast body of code that can potentially offer us. And again, I want to go back to this idea of conversation. It's that idea. It's a dialogue. If you start looking like that, I think you're more likely to get good results.
All right. And to kind of close the loop, what are your views on Any and its evolution from Boost to the standard?
Okay, the Any question. Yeah, so Any has a long history, a pre-standard history, a pre-Boost history, and I came across the term Any in there's a lot of kind of type theory papers and things in the 70s and 80s, and then ASN1, abstract syntax notation for specifying what should be transferred in the protocol. They all have a type called Any, and it's this kind of universal type that's not necessarily a root type. And I was working on a system where we needed to have such a thing, and I worked out you could do this generically. The problem is we couldn't actually use the templates that we wanted to at the time, but I worked out in that case, okay, how do I dumb it down to the types that we are likely to use, the basic vocabulary types that we're likely to use. But the whole idea of having a universal type, if you like, a type-safe void pointer, but that's value-based, was one of those things I was very interested in. In fact, that old project I discovered afterwards, they started joking about the whole thing after I left as Kevlin Henney. It became known in the code base from that point of view. But when Boost started up, it was one of those things that I've contributed 3 things to Boost, 2 of which are about weakening the type system, 1 of which is about strengthening it: numeric cast, lexical cast, and Any. And Any made it into the standard, and that was, it had undergone. I introduced it originally in a C++ report article, over 20 years ago, 25 years ago. Then I submitted it to Boost, adding a little more complexity, so on. But then I passed off the ownership of that to others, and it's evolved there. But it's actually kept its simplicity. It was always intended to be. It's got to be a simple type. It can take absolutely anything. It's not a kind of constrained union type like variant, so therefore you don't know its content. You have to, if you can just pass it around, or you can ask what it is and get values out of it, but you can't do anything that is any more sophisticated than that. It was never intended to be any more sophisticated than that. So I'm actually surprised that over time it has become, it stayed as consistent as it was. Now, it was standardized. It was included in C++ 17. The late Beeman Dawes was primarily responsible for taking the original text and tightening it up, and I just gave review comments and so on. Beeman did a really great job there. But how do I feel about it? I wish it had been different, because by the time you got to C++ 17, this type was nearly 20 years old, and C++ had gone through a number of standards. So with hindsight, I wish it had been more consistent in its appearance. In other words, we could have changed certain things, names and syntactic conventions and usage conventions. I think that optional, variant, and any should have a lot more consistency. And that's unfortunately because C++ doesn't have a kind of binding vision. They were standardized as they were because they came they had a source, boost in the case of variant and any, and they were left very much as they were. So they were still compatible with those old versions. I actually think they should have been changed in a way that was not compatible. That's the whole point of namespaces, is so that they were more consistent with each other and they had reflected the standardization trends and idioms that have been acquired in that time. So I still retain I love the basic idea. I would stick with that. But I kind of like the way that variant and optional do things a little bit more these days. And I kind of wish any looked a bit more like that.
And I think there's one more question, and then we're going to close because it's already going on for a while. I think this is the longest edition we have so far. Do you have some favorite feature introduced to C++ 11 and or like between 11 and 20? Let's keep this one question. You would like to highlight and like a lot?
Oh, that's a really good question. Okay, if we're going to go for the easiest thing, I'm going to say auto.
Okay.
I'm just going to say auto. I'm just going to say the compiler, having the compiler do all the stuff the compiler already knows. You know it, the compiler knows it, but somehow we've got to feed the syntax. It's just like, oh my goodness, it was all the machinery was there. It's so many. It just the syntactic weight. For those of you who've never worked in just straight C++ 98, you have no idea what that's like. The sheer syntactic weight of the language was huge. And, it's just being able to say a little more directly. So yeah, actually, I'm going to be really simple on this one. That actually changes the stuff that you write on the minute-to-minute basis. It changes the stuff you'll feel. Feel stuff you're going to feel comfortable about. You're more likely to embrace things that are a little more complex and not get lost in that. You can see the code more clearly. I think that is the simplest usage level change that transforms the appearance and the feel of the language.
Do you agree with Herb that you should then always use auto?
Oh no, I don't. No, I'm not an auto anywhere. There is a whole spectrum. No, I know Herb is very much just use it. I don't agree with that, and I don't think that is necessarily necessary. And sometimes you can end up with great contortions with an auto over here, and then an initializer that kind of feels a little bit unnecessary. That you're kind of forcing a lot of the type name stuff over onto the right hand side. And you're making a more complex expression elsewhere. Now, I definitely have a kind of set of rules that I would tend to follow in a number of cases for when I would use auto and when I wouldn't.
Okay, so and this, I guess, just gonna say this is going to be the whole session we have. It was really, really awesome.
Thank you very much, Jens. That's great stuff.
And thank you, Kevlin, for being our guest and staying for so long.
Thank you. And thank you for your questions, folks. Sorry if I didn't answer them to your satisfaction. I know there are a couple of things there, but no, the great questions all the way through. Thank you.
Yeah. So with that, we're going to end the session.